Good morning, ma'am. Am I audible? Anyone please confirm, am I audible? Very good
Yes,
morning,
ma'am.
Sujit. Thank you, Shakshi. Okay, ma, I'm Ramya. I'll be handling advanced computer networks for you people in this semester. Okay, I've shared the handouts. You could have seen the handouts already uploaded in Teams. I'll be uploading all the annotated slides in the Teams. If just a second. If you want, even without annotation, it will be uploaded in Taxilla. Okay, so after completion of each and every session, I'll be uploading the slides in the Teams. Annotated slides will be available immediately after each session. Okay, if you have any doubts, please interrupt and you can ask questions. Fine. Just a second, I'll share my screen and we'll start the session. I think already you would have studied computer networks in the previous semester, right? Yes. Please confirm. You have studied computer networks already, right? Yes, fine. Okay. If you have any WhatsApp group, ask your friends to join the meeting, Kana. Hope my screen is visible. Yes. Okay. Uh, you would have studied computer networking. That is the prerequisite, fundamentals related to computer networking. Uh, Course outcomes. These are the course outcomes which will be available in the handouts. And this is your text. These two are the reference books. Okay, computer network system approach by Peterson. That will be your text. You can even refer the text. So these are your handouts. It has been divided into 8 modules. Okay, and it is a lab component course. We'll be seeing or we'll be running certain programs with the help of Wireshark, Cisco Packet Tracer, and NS2. Okay, we'll start with the first module, that is Internet Architecture and the next generation Internet Design. That is what the agenda for the today's class. Okay, functionalities. What is the network? What are the components in the network? Architecture, network architecture, and we'll be moving on to internet architecture. Then we'll be seeing next generation internet design. Okay. So what's a computer network? Already you've studied, right? What's a network? What is a network, ma? I've given privileges to unmute your mic, or else you can use the chat box to answer the question. What is a network? It is a basic question. What's a network? What is a computer network? Group of devices. Oh, computer. Fine. Sujit, thank you. So, group of devices, computers, which will be connected together. So what is the purpose of the connection? In order to share the information or the resources. Okay, so group of autonomous systems that will be connected together for sharing, exchanging information, and also the resources. So autonomous, what do you mean by the word autonomous here? So we have referred a word autonomous. So what is autonomous? Each computer will be functioning independently. Okay, so when it is network, they can work together efficiently, but autonomous in the sense each and every system will be working independently. So computers will be connected and they'll be exchanging information with one another with the help of a physical connection. Okay, or else there are different sort of connections we'll be seeing, guided media or with the help of unguided media. So what is the purpose of exchanging information? So exchange whatever the information that is being exchanged, that will be referred as data. Okay, so the data can be in the form of text, images, audio, video. Okay, whatever the format that is being understandable by both the parties, that is sender and receiver, the information will be exchanged. Okay, so for data exchange, if whatever the data that I'm sending to the receiver, if that is to be meaningful in that sense, the sender and receiver, they should agree certain structure. Why? Because the platform will be different, right? And also the architecture will be different, right? So if one system is having 32-bit processor, another one is having 64-bit processor, which uses, this one uses little Indian format and this one uses big Indian format. And also the platform operating system is Windows. If I say Windows, here I'm using Mac OS. What will happen? So both are different, right? So they need to follow a common structure in order to exchange the information. So if the information need, if it is to be meaningful, they need to follow a structure. That's the reason interpretation of the data should be meaningful in both the systems. For that, both the systems need to follow certain structure. So the data communication is nothing but we'll be transferring the data between the devices through any of the medium. Either it could be a wired medium or a wireless medium. Okay. So whatever the data that is being delivered, that should be delivered accurately. And also it should be delivered securely. Okay. So from one device, if I'm sending a data, that should be interpreted properly and it should be delivered accurately, securely. So computer networks, it enables communication and also it allows coordination so that the resources sharing can be done. The data can be exchanged between multiple computers. So all these things makes faster processing. Okay, the task will be executed more faster way and in an efficient way. That is the main purpose of computer networking. Okay, so what are the network functionalities? So network functionalities, the first function is to discover the nodes on the network or the internet. Okay, so I need to identify the devices that are available, that are active for the communication. So it can be identified with the help of, if it is within the network, it can be identified with the help of one address, and if it is in the internet, it can be identified with one address. Can you please name the addresses for network? Which address is required for internet? Which address is required? So you would have studied two types of addressing. Do you remember that? Types of address. If I want to identify a system within the network, which address will be used? This one is also a very basic question. Ajay, Ajit, Arjun, Anurag, Abhishek. One is in the meeting. Now, what are the addresses you have studied in computer networks? Shivam, Sujit, Saptami, Salma, Priya, Sai Durga, Ranak, Kunal, Omkar, Mehra. Super. What are the two types of addressing that you've studied in computer networks? One is MAC address, another one is IP address. For network, MAC address is more than enough. And for internet, IP address is required, right? So in order to discover the nodes, addressing is required. So if I want to discover the system within the network, MAC is enough. If I want to identify a system within the internet, I need an IP address. So network must be able to route the packets. So selecting the best path from the source to destination based upon the availability, speed, cost. It could be anything. Okay. So since different networks may support different packet sizes, the network should be able to handle fragmentation and also reassembly. Okay. So packets, route the packets, we need fragmentation, fragmentation and reassembling is required. Okay, why it is required? In order to ensure the data is transmitted correctly across all the segments. And also the network must be capable of meeting application requirements. Okay, packet size requirements, and also it should meet the application requirements. Okay, so if it is video call, I need to give lower latency. So if I want to transfer the file, I have to give high throughput. So depending upon the type of service, the application requirements differ. Okay, so the reliability, the first one is the reliability. The reliability is nothing but the network must protect against data loss or the duplication or corruption. So we have to ensure accurate delivery. Okay. Next one is congestion control. So network must be capable of implementing congestion control. So what is the purpose of doing that? In order to prevent overloading. When many devices transfer the data at once, what will happen? Everything will be congested and packet loss will happen, right? So packet loss, collision results in again retransfer. Again, the network will be congested, overloaded, and it will be congested. So, and another one is flow control. Flow control, you have to match the flow between the sender and receiver. So, if I have an overwhelming sender and my receiver is a slow receiver, so if I transfer my bottle size is 1 liter, but I'm pouring 1.5 liters, half the liter will be wasted, right? So, if you want to match the speed between the sender and receiver. And the next one is in-order delivery. So you have to ensure the network must ensure in-order delivery. So whatever the packets that arrive at the destination in the public packet switch network, we cannot ensure all the packets arrive in the same order. Okay. So some flow in different paths, some will take different paths. So packets will be delivered or will be received at the destination in out of order. With the help of a segment number, we have to reassemble it. Okay, so these are the application requirements. Right? So what are the 5 components of the data communication? First one is the message, actual data or the information that is need to be communicated. Okay, so it can be a video file, a text file, image, or any digital form that can be sent. Okay, that is your message. The second one is the sender. So sender is nothing but the system that will be generating and sending the message. Okay. So from the computer, you can send the message. From the smartphone, you can send the message, or any other communication device initiating the data transfer. That will be the sender. Okay. Third one is the receiver. Receiver is the device, is the system which is going to receive the message. Okay. So even it can be a computer, phone, any other system accepting and processing the transmitting message. Okay. Fourth one is the medium. Okay. A physical part or the logical part where your message travels from the source to destination. Okay. So fiber optic cables, twisted pair cables, or even the air. Okay. Wireless medium, Wi-Fi. It could be the medium. Okay. And the fifth one is the protocol. So protocol is nothing but a set of rules. Okay. Already in the previous slide, I've told you all this is in the network or even in the internet. I cannot instruct all the users to use the same architecture and same platform, right? So if you want to have know how the data is transmitted and interpreted between devices, we need to have a set of rules. Okay, so those set of rules are called as a protocol. So it ensures sender and receiver understand the format. Okay, so whatever the data that is being exchanged, successful communication is happening between the sender and receiver with the help of this protocol. So these are the five components. What are the five components? Actual data, that is message, sender, receiver, fourth one is medium, and the fifth one is protocol. So these are the five components of data communication. Okay, now we'll see the network structure. So network structure, we start with the network edge of the system. So what will be there at the edge of the network? What will be there in the edge of the network, ma? So the network you have at the core, you will have edge of the network and core of the network, right? So edge of the network, you will have what will be there in the edge of the network and what will be there in the core of the network. So this is the edge, right? And this is the core. What is there in the edge and what is there in the core? Students, are you there in the meeting? Now, what is there in the edge of the network? Since this is the first class, I've asked some of the students, I didn't remove you from the meeting. From the next time onwards, if I'm asking any question, if you're not responding, I'll just remove you from the meeting and I'll lock the meeting. Sujit, I've asked, please listen to the lecture. I asked what will be there in the edge of the network and what will be there in the core of the network. That's what my question. Vikash, yes, very good. Edge of the network will be the devices, excellent. It could be the applications, end systems, servers, smartphones, computers, client machine, a server machine. Yes, you're right. What will be there in the core of the network? Core of the network will have metrics of speed. Oh, routers and switches. Salma, you're right. So core of the network, you have routers in the internet. We have routers. Okay. So network edge is nothing but where the applications and hosts will be there. So part of the where the end users, applications, everything will get operated. Okay. So a computer, a smartphone, a server. Okay. All these things are referred to as host. Okay. So which run on the applications that send and receive the data. Right. And in order to connect to these edge devices to a larger network, we use access networks. Okay, so these are the initial communication links. Say, for example, Wi-Fi. Wi-Fi is an example. Here, Wi-Fi is an example. Okay, so any mobile data networks or even the enterprise lines. Okay, that will make a first point of access to the internet. Right. So these access networks will be built using different physical media. It could be a wired communication or wireless communication. So wired communication in the sense Ethernet cables we'll be using. If it is a wireless communication, we will be using Wi-Fi and the mobile networks. Right. At the center, we have core of the network. This is actually the core of the network core. Right. Fine. So it will be having interconnected routers. So these routers are the one responsible for managing and forwarding the data between different parts of the network. Okay. So the core forms the network of networks. Okay. So which is what we commonly refer that as internet. Okay. A global system of interconnected networks. So what is the purpose of doing that? To connect worldwide to communicate with one another, right? So the network structure will have edge, access networks, physical medium, and the network code, right? So we'll see each and everything in detail. First one is edge of the network. So edge is nothing but where your end systems will operate. Okay, so those are called as host. So host will be located at the edge of the network. These are called as end systems. So some of the examples are smartphones, tablets. Okay, they run application programs at the edge. Okay, what are the programs? A web browser is an example. Email or messaging applications. These are the applications which will be running on the host network, right? So these applications will operate at the edge of the network. So they'll be starting the communication. Okay. They'll be the starting and also they'll be the ending point for the data communication. So when you browse a website, okay, or even when you send an email, the activity begins at the system. Okay. So from your laptop, you're browsing something, right? Requesting a homepage, google.com, right? So this way your communication gets initiated. So it will be referred to the internet. With the help of an internet, it will be routed to the appropriate server and the server will be responding. So where will be the server? Even the server will be located at the edge of the network. Okay, it will respond. It will reply with the homepage of Google, right? Or even if you send a mail, okay, so with the help of a phone you're sending an email, okay, so that will be with the help of a server, it will be routed and it will be sent to the appropriate user. So all the end systems, the starting communication and the ending point of the communication begins and ends at the edge of the network. So in the client server model, the client will be sending a request and the server will be responding the communication. Okay, so we have seen an example where how a browser is requesting the data, how an email is sent. Okay, now that is your client server model. We have seen an example. The next one is peer-to-peer model. So peer-to-peer model, there'll not be, we'll be minimizing the use of, I cannot say there will not be any dedicated servers. We'll be minimizing the use of dedicated servers. Okay, so the device will act as both client and server. So it will share the resources directly with each other. So applications, Skype, BitTorrent, they use the peer-to-peer model. Okay, so users communicate and share data without a central server to manage the process. Fine. Any doubts as of now? Any doubts, ma? In a peer-to-peer network, Sujit, there will not be any centralized systems. The client, you have centralized systems. Centralized systems will be, the server will be responsible for all the actions. But the peer-to-peer network, there will not be any server, dedicated server. Central authority will not be there. All the system can be a client as well as the server. Okay, so I cannot say I cannot use the term client and server. Everyone will be responsible for sending and receiving the data. There will not be any central authority. That is your peer-to-peer server. Sorry, peer-to-peer model. Any doubts? Sujit? Any other doubts, ma? BitTorrent, Bitcoin, all these things are the examples of peer-to-peer model. Right? Now we'll see network architecture. So network architecture, it is a structured design. As you can see, it's a structured design. Right? So how the computers and devices, they can communicate within the network. So they organize the communication with the layered architecture. They use a layered architecture. Right? So you will be having different layers for simplifying the interoperability, right? So at the top, we have application program. So it's a software applications. Just now we have seen a browser, email. Okay, so all these things are examples of application programs. Okay, so the next one is process to process channels. So process to process channels, they means how the data is being exchanged between the processes running on different systems across the networks. So say for example, I have a system. Okay, so with the help of a, this is my a local network. Okay, local area network. At the edge, I have a router, which we'll be calling as a edge router. It will be connected to core routers. Interconnections will be there, and some other system will be connected, right? This is how, this is an example of your internet, right? So if I want to send a message from the system, say for example, 172.168.20.1, want to send the data to 192.168.10.10. Fine. So I want to share the data between these two systems. Whether it is more than enough to identify only the system in the internet. So with the help of the IP address, I can identify. But what is the next problem? Here, how many processes are running here? I've opened 3 applications, 4 applications. How many processes are running here? Even in my system, how many processes are running here? Could you able to see this? I've opened the task manager. I've opened 4 applications. For these 4 applications, how many processes are running? These are daemon processes. How many processes are running, ma'am? Are you there in the meeting? Total 86. Oh, fine. So these are applications, Kana. Salma, these are applications. In order to support these applications, we'll be having 82 processes. Okay, these are processes. Now, sometimes it becomes 82 or 88, 83. Processors will differ. Okay, even in order to support teams, okay, certain number of processors are required. Okay, for sending the data, video, audio separately, there will be different number of processors. Okay, running on the system, right? So how the system will able to, it is not only I need to identify the system with the help of an IP address. I need to say, so out of 82 processes, to which process I want to share the data. So see here, randomly it gets increased or decreased. Okay. So if I want to send the data, it is not only I need to identify the system with the help of an IP address. I even need to inform to which process I'm sending the data. Okay. So how I can identify the process? How a process can be identified? So that's the reason process to process communication is required. So TCP, the transport protocol, is responsible for process to process communication, transport layer. How a process can be identified in network? We have seen MAC address, IP address. How a process can be identified, ma? With the help of a port number. Okay. So port number, with the help of a port number, I can able to identify to which process I'm sending the data. Fine. Process to process communication will happen with the help of a port number. So from the system will have multiple number of processes running, and also here will be having multiple number of processes running, right? To which process I'm sending the data, that will be identified with the help of a port number. So that is your process to process channel. The next one is host to host connectivity. The computers connections, the reliable path for the communication. Okay. So IP address. Okay. Addressing is required. Addressing, routing, error handling. And the next one is hardware. Hardware layer, the physical device, how the transmission media is connected. Whether I'm using guided media like cables. Okay. So with which can be routed with the help of switches, routers. Okay. That is your hardware. So this is the example of the network layer system. Okay. So for OSL layer, we'll be having different layers. We'll be seeing the upcoming slides. Okay. This is actually the a simple network architecture. Okay. So the network architecture, it is a structured approach in order to define how different components of the network can interact. Okay. So it will be functionality. The functionality will be divided based upon the layers will be divided based upon the functionality. Okay. So already we have seen application program. Here, the communication abstraction, the different communication abstraction, we can have two types of communication. The first one is request reply or message string channel. So the request reply channel, one side will be sending a request. Okay. So if I say a client will be sending a request. For this request, the server will be sending a reply. Okay. The best example is HTTP. HTTP request and HTTP reply, or DNS. DNS request, and we'll be resolving the DNS query. Okay. That is an example for request reply. The next one is message string. So continuous streams of data will be exchanged between the applications. Okay. So I cannot say this is my sender, this is my receiver. I'm sending video calls or file transfer. Continuously, I'm sending the data with the help of a TCP. Okay. That comes under message stream. This is your request reply. Okay. host to host connectivity, hardware, what is hardware layer? Already we have seen. So layered system, each layer will be providing a particular services to the particular in the layered approach. Okay, depending upon the services below and above, it will be doing certain functionalities. Fine. So the next one is protocol. So protocol, it is a set of rule. Okay, what is the purpose of defining the rule, or what is the purpose of giving the rule? So you need to define how the data should be interpreted. Okay, how it should be formatted, how it should be transmitted, how it should be received across the network. Okay, in order to ensure the devices can be communicated in an accurate way, reliable way, in a smooth way, we need to define a set of rules. So we have the protocols will be defining interfaces between the layers. Okay, how the transport layer will be interacting with the application layer. Okay, so how the two layers can be interacting, that will be defined by a protocol. And also it will be, they are the building blocks of the network architecture. So each layer of the network layered architecture will have a specific protocol. So application layer, which uses HTTP. Transport layer will be using either TCP or UDP. The network layer will be using IP. So each and every layer will have a specific set of protocols. So every protocol object will have two interfaces. Okay. So two interfaces in the sense they'll be having service interface and peer interface. So service interface is nothing but it will be defining how the upper layer can use its services. Okay. And the peer interface will define how it communicates with the counterpart and the another system. So it, in order to have an end-to-end coordination, peer interface is required. Okay. The next one, protocol. Protocol is nothing but it refers to many things. Okay, so we can describe a full communication standard with the help of TCP/IP protocol suite, or a small part with just rules for messaging, formatting, or message error detection. So it is protocol. The term protocol, it is overloaded. Okay, so it can refer many things. That is what here meant is. Okay, the next one is interfaces. Interfaces, the layer network architecture, interface will define how the different layers will interact with each other, or how it will interact with other protocol in the counterpart on other system. Okay, so two types of services just now we have seen. One is service interface, another one is peer interface. So what is service interface? How the interface will be communicating, or how it will define uh, uh, the service interface will be usually defining, this is your service interface, uh, how the layer above uses the services provided by the layer below. Okay, so transport layer, if I'm taking this one as application layer, and the layer below, if I'm taking it as transport layer. Okay, so how the application layer uses the services of the transport layer for sending the data across the internet. That is your service interface. Okay, so it specifies the operation available, what are the parameters that should be provided, what is the result expected. Okay, so those are defined by the service interface. Okay, the next one is peer interface. As you can see here, how it will be defining how a layer communication with the peer layer happens. Okay, so two systems are there, host 1 and host 2. How the transport layer in host 1 is interacting with a transport layer in the host 2. That is your peer-to-peer interface. Okay, so everything will be supported with the help of a protocol. Fine. So service layer, above layer, and the peer layer, it is the so how the interface are connected to the same layer across different systems. That is your peer interface. Fine. Any doubts, ma'am? Do you have any doubts? ensure you don't get disconnected. The next one, you'll see protocol graph. Protocol graph, it is the visual representation which will be providing how the different protocols in the network architecture related to each other. Okay, so here, see here how these are interconnected to each other. Okay, so the nodes represents the protocols: HHP, RRP, MSP. These are the protocols. It can be HTTP, TCP, IP, Ethernet. So these links, it tells how it depends, or it shows the depends on relationship. Okay, so which will be telling how one protocol is relied on another protocol in the function. Okay, so for, say for example, how the RRP depends on HHP, or how HHP is depending on MSP. Okay, so it depends on relationship, how it is been in the physical network protocol like Ethernet, Wi-Fi. That will be indicated with the help of a link. Okay, so this layer dependency, it will be showing how the higher layer protocol is built on lower level ones. Okay, so for providing reliable communication, each layer will provide services, right? So each layer will be provided services to both the layers, the above layer, also the below layer. So the protocol graph, it tells you the modular structure of the network protocols, how it is responsible and how they are divided across the layers. Okay, so how the multiple protocols depend on the uh, lower level protocols or the higher level protocols in order to provide the reliable communication. This is the example of the protocol graph. Okay, so the next one is encapsulation. Encapsulation is nothing but how the packet is packaged, how the data is packaged for transmission across the layered architecture. That is called as an encapsulation. Okay, so when a high level application, when the application program sends the data, so the data alone will be sent to the next layer, right? So here the next layer is RRP. RRP receives the protocol. RRP is a protocol, so which will be providing its own header. The data will be wrapped with the RRP header and it will be given to the next layer. So the next layer which uses HHP protocol. HHP protocol, what it will do, this, what will here, it will consider this as the entire message. Okay, this will be placed inside the payload and it will be having its own header. This is called as encapsulation. Fine. So encapsulation is nothing but the process of wrapping the payload and providing a header is called as an encapsulation. So what will be the decapsulation? Decapsulation is the reverse process where you'll be removing the header. Okay. So when it receives an HHP, when it is given to the higher layer, so it will remove its own header and it will be providing only the payload part. Again, RRP, when it is providing the data to the higher layer, it will remove its own header and it will be providing the data. So removing the header and passing the remaining message to the layer above is called as a decapsulation. What is encapsulation? Encapsulation is adding the header and placing the data in the payload part and adding the header is called as an encapsulation. Okay, so these two are required in order to provide certain functionalities. We'll be seeing everything in detail. Fine. Next, we'll see OSI architecture. What do you mean by OSI? Open System Interconnect, right? So Open System Interconnect, it was developed by ISO, International Organization Standard, International Standard Organization, right? So OSI model, we'll be dividing the layers into 7 layers, starting with application layer, presentation from top to bottom. I'm saying it is a top-down approach. Okay. Third one is session, transport, network, data link, and physical. Right? So application layer, how the end user application operates. Okay, the web browser is an example. Presentation layer is responsible for data translation. It is also responsible for encryption, compression, everything will be done by the presentation layer. Session layer in order to handle the sessions. Okay, session, the dialogues between the applications. Transport layer is for end-to-end communication. Okay, that is process to process communication will be taken care by the transport layer. Network layer, it is host to host communication. Okay, data link layer it is for node to node communication. Okay, so the physical layer for sending the actual transmission of bits. So as you would have studied, these three layers represent the data in terms of data itself. Transport layer represents the data in terms of segments. Network layer, packets. Data link layer, frames, and physical layer, bits. Okay, each and every device will be operating in different layers. That also you would have studied in computer networks. Right? This is all about a small introduction of OSI architecture. Okay, so how the client and server is interacting. So client is opening a browser and it is requesting a web page, google.com. Okay, so three-way handshaking will happen between client and server, right? So before actual data has been requested, the three-way handshaking will happen. How it will happen? Thing will be transmitted by the client. For that, SYNAC will be transmitted by the server. Then again, SYN will acknowledgement for this SYN will be transmitted by the client. So this is called as three-way handshaking. So one three-way handshaking is done, the data communication is initiated. So the client and server can start the communication. So this is one process and this is another process. So client process will be identified with the help of a port number. Okay. So server process will be identified by the well-known port number, right? For HTTP, we'll be using 80. That's why when you configure, you'll be providing 8080, right? Client machine, it is need not to be a well-known port number. We can use any port numbers between 400 to 1200. Okay, it could be even you can have port numbers are from 0 to 65535. Okay, so well-known 0 to 1200 will be the well-known port numbers. Right. So apart from that, any port numbers can be used by the client process. It need not to be a well-known port number. So it will be requesting the providing a request. Say for example, HTTP request. A process-to-process communication will happen, and the server will be replying with HTTP reply. Right? This is how the communication, actual communication, happens between the process to process. Okay, not from the system to system. It is done by the process to process. Okay. Any doubts? Only Sujit is in the meeting. What about others? Any doubts, ma? See, from the next class onwards, don't ask me to. Vikash, thank you. Unlock the meeting. Now we'll see the connection-oriented service, the difference between connection-oriented service and connection-less service. So connection-oriented service, a connection will be established, right? So it will be established with the help of a call setup. Okay. Then after the call setup, the data transfer will happen and the termination will be happening. Okay. Finally, the connection will be terminated when the communication is completed. Okay. So it will be providing a reliable communication. Okay. All of the message will be preserved and the data will not be lost. No loss of data will happen. Okay. It will ensure reliable communication. So for reliable data transfer, it uses the acknowledgements. Okay. For confirming the successful delivery. Okay. Or else if the delay is happening, it will be initiating the retransfer. Okay, once the timer expires, it will be initiating the retransfer. Again, the data will be transmitted and the acknowledgement will be received. The example is the phone call. Okay, or else the file transfer. Okay, so how the file transfer protocol works. The files will be transferred successfully, and after that, for that file transfer, the server will be responding. So if I have a client and server, what is called setup?
बट मैं ऐसी जादू की तरह नहीं
Rahima, can you please mute your audio? So if you do it for the next time, I'll just remove you from the meeting. Then the NAC. This is call setup. Then the data transfer will happen. Then FNAC, ACK. The call termination will happen. Okay. So once it is sending the request, it will start the timer. Okay. If the timer expires, so within the meanwhile, if I'm not getting the reply, if the timer expires, the retransmission will be triggered automatically. Okay. So this is how the reliable communication happens. Fine. The next one is connectionless service. The connectionless service, the packet will be sent immediately. So each packets will be taking a different route to reach the destination. Okay, so the routing decisions will be made by the intermediate nodes. Okay, so how the packet should be routed. So the routing decisions will be made at the intermediate nodes, or it will be made by the router. Okay, so email, remote login, telnet, IP. So all these things are examples of by a connectionless service where it will not guarantee the packet order or it will not even guarantee the reliability. So it gives you the flexibility and robustness. Okay. But we cannot guarantee the delivery of in order delivery of packet as well as in order delivery. Right. So it will be avoiding unnecessary overhead. Now we'll see access network. So access network is nothing but an infrastructure which connects the end systems. Okay, so that is your access network. In the previous slide itself, we have seen how the end systems are connected with the help of routers, or it could be multiple devices. How these things are connected together. Okay, how the computers, smartphones, IoT devices are everything are connected to the edge router. So as you can see here, this is network 1, network 2, and network 3. This is my internet. That is your core of the network, right? So this is your access together. It is called as access network. So for every access network, as you can see here, edge router is there. So these are called as edge router. Edge router is responsible for connecting the network to the access network to the internet. Okay, so the main goal of the access network to provide the initial connectivity. Okay, from it could be the home or an institution, okay, or a service provider or a residential access network. So initial, how the initial communication is provided. So that will be provided with the local area network, right? The DSL, cable modem, fiber to home. These are the examples. Okay, how it is connected. So Wi-Fi is also a best example. Right? So this is an example of institutional access network. Okay, how it works in an institution like a Wipro, right? Or BITS Pilani. Right? So again, it will be extended together by making the edge router connected to the internet. Okay, so dedicated lease lines will be connected to the edge router so that the bandwidth and security, high bandwidth will be provided. So this institution network can make use of the internet connectivity. Okay. So from the initial connection, how it is being connected to the internet. So access networks will have a different speed, different cost, different coverage. But if it is connected to the internet will have a different properties like speed, cost, average, and all. Okay. So the purpose of getting user devices connected to the internet in order to access the make another access networks to get connected. That's it. Fine. The types of medium, guided medium and unguided medium. So guided or it is called as wired, unguided or it is called as wireless. So guided media, the physical cables. What are the physical? Three main physical cables are physical, twisted pair cable, coaxial cable, and fiber optic cables. Right. So these media will be providing a point-to-point communication. So the data will travel directly between 2 points from the source to the destination. So the signal energy will be contained and it will be guided within a solid medium. Okay. So it will prevent from spreading or leaking. Okay. It will be contained and it will be guided within the solid medium. So the installation process here, the installation process is complex and also it is very expensive too. And it is time consuming as well. Okay. So when laying the cables across the building, it is time consuming, right? And the network topology is required and it is discrete. So connections, you need to provide the connections very clearly and it should be provided in a structured way. So that's what the network topology is. They say it is discrete. And also attenuation in guided media, attenuation will be there. So attenuation is nothing but loss of signal strength. Okay, so when distance is increased, attenuation is directly proportional to the distance. Okay, so when distance increases, the attenuation is also increases. Okay, so longer cables will reduce the signal quality. In that, what do you mean by that? Longer distance will increase the attenuation. So if more transmission capacity is needed, we need to add more wires and we need to add more fibers. Okay, scalable is complex for certain setups. So this is what related to guided. So what about unguided media? Unguided media, infrared waves, radio transmissions, microwave transmission. So which will be other signals transmitted to the air or the space. Wireless communication, always it will be broadcast in nature. So what do you mean by broadcast? Signals can be received by multiple devices within the range. Okay, so your television broadcast is done with the help of an Airtel or Geo. Multiple set of boxes you have, right? So it is a broadcast transmission. Even FM, it is a broadcast. The best example. Okay, so the signal energy will be propagating freely and also unguided electromagnetic waves will be there. It will not be contained or confined to the medium. Okay, why? Because the electromagnetic waves will be spread. FM, you can hear the FM in the smartphone, right? So there is no connection. So even you can listen. Why? Because with the help of electromagnetic waves. Okay, so without a wire, you can receive the signals. So wireless, it is quicker. Of course, it is quicker to set up. Cost is effective and sometimes you require antennas and transceivers. What do you mean by transceivers? To transfer and receive the messages rather than the cables. Okay, so as you can see here in the vehicles, you'll be even in the car, the antenna will be there. Okay, in order to receive the signal. That is very required. And also the network topology is continuous. So it is flexible and it supports movement and easy to expand as well. Okay. So attenuation here, the attenuation will not directly proportional to the distance, but attenuation increases logarithmically with the distance. That's what is referred as attenuation directly proportional to logarithmic of the distance. Okay. Signal loss, it will be growing more slowly over the distance when compared to guided media. Okay, but it is very susceptible to the interference. Right? So it is not possible to simply add more air. Right? That is not possible. If I want to increase the capacity, it is not possible to add the air. Here, if I want to increase the capacity, I can add more wires. But here, what is the medium? Air is the medium. I cannot add more air, right? So wireless systems, they are they require more complex solutions. Okay, in order to spread the signals, spectrum allocation is required, or more advanced modulation is required. Okay, that is the main difference between the guided and unguided media. Any doubts, ma'am? Do you have any doubts? So now we'll see network core. What will be there in the core of the network? So core is nothing but this is what the core, the central part of the internet. Okay, mesh of interconnected routers. As you can see here, all the routers will be interconnected. That's what they say, mesh connection, mesh of interconnected routers. What is the purpose of doing this connection? In order to forward the data between the source and destination across different networks. Okay, how the data will be transferred from the network. So how it will be transferred from the network? With the help of either circuit switching or packet switching. So circuit switching is nothing but a dedicated communication path will be there. Okay, the sender and in between the sender and receiver, there will be a dedicated path so that the transmission will happen. That is your circuit switching. The next one is packet switching. So even if the sender and receiver is not sending the data, the path remains reserved. Okay, for the entire duration of the session. Before landline, before decades, everybody will have a landline at home, right? So a wired connection, a dedicated wire will be there. So even if you get a call or not, a dedicated circuit will be given. Okay, so that will be used for that device, right? For the entire duration. That is your circuit switching. The next one is packet switching. Packet switching is nothing but their data will be broken and it will be divided into smaller units, which is called as packets. And these packets will be sent independently through the network. So each packet can take a different path to reach the destination. So on the destination side, if it is received out of order, it will be reassembled. Okay. So the best example is internet for the packet switching. And for circuit switching, telephone network is the best example. Okay, guaranteed bandwidth and consistent performance will be there, but the resources will be inefficient. We will not be using the resources in an efficient way. Okay, so it will be providing better bandwidth. Okay, so many users can transfer the data at the same time. So variations, delays, and variations in the packet arrival is possible. Okay. Now we'll see the internet structure. Internet structure is nothing but network of networks. Network of interconnected networks. So each network will be managed independently, but it will cooperate to enable global data communication. Okay. So it is a hierarchical way of connecting. So from the organized levels based on the sizes, reachability, and the role of the network, it depends. Okay. So at the top of the hierarchy, you'll be having Tier 1 ISP, Internet Service Providers. Large, powerful Internet services providers will be there. Example, AT&T, Cable and Wires, Verizon are the examples of a large ISPs. Okay? So these Tier 1 ISPs, they have nationwide connection. Okay? Or even international coverage. They'll be interconnecting with each other So they'll be forming the core of the global network. Okay. So the tier 1 ISP, they'll be connected to each other and even they'll be treating each other as equal. Okay. So they engage in peering agreements as well. Okay. They exchange traffic without charging each other. Those benefits will be between the tier 1 ISPs. The next, they'll be interconnected and they'll be treating each other equal. They'll not cost, they'll not ask for the cost. Okay. So they can share accesses. Sharing access even can be provided extended to the customers as well. Okay. So below tier 1 ISPs, you'll be having tier 2 as well as tier 3. So tier 2 and tier 3, they need a payment for the connection. Okay. If they want to connect to the tier 1 ISP, they need to pay for the high level ISPs. Okay. So we'll see that here. This will be interconnected. Okay. So the next one is tier 2 ISPs. Okay. So tier 2 ISP, they are smaller ISPs. Okay. Which will be connecting the region. So here it is nationwide or sometimes international as well. So, but tier 2 will be accessing, will be operating at the region wide. Okay. So below the tier 1 and the hierarchy. Right. So tier 2, they do not have a global network, but instead they'll be connecting to the tier 1. Okay. They'll be purchasing internet connectivity from or tier 1 ISP or even from one or two tier 1 ISPs. Okay, in order to gain the access to the broader network, they even will be getting the connection from one or two tier 1 ISPs. Okay, so tier 2 ISPs, they also connect to each other. Okay, with the help of peering agreements that also can be done for exchanging the traffic locally for reducing the cost. Right? So these tier 2 ISPs will be intermediaries between the tier 1 ISPs. And also they'll be acting as an intermediate for the end users as well. Right? They provide broadband access, email hosting, domain registration, local content catching. Everything will be done by tier 2 ISP. The next one is the tier 3 ISPs. So tier 3 ISPs are local, lowest level. In the hierarchy, the lowest level will be the tier 3 ISPs or the local ISPs. So here they are international wide, they are regional. Here tier 3, they are local ISPs. Okay, small local providers. So for they'll be concentrating individual homes, a small business, or an institution. Okay, so they'll not be connecting directly with each other. So tier 1 will be connected. Definitely they'll be interconnected. Tier 2 sometimes they'll be interconnected with each other. Okay, so but tier 3 will not be interconnected. So they'll be operating at an independent one and they'll be providing the access network. So tier 3 is responsible for providing the access network. Okay. So whichever the network closest to the end system that can be connected. So the laptop, smartphone, smart home devices can be connected. So they are responsible for managing the physical connections to the end users. Okay. So cable internet, wireless broadband, Wi-Fi, everything can be provided with the help of a local ISP. Okay. So they can provide internet access to the general public. That's it. Okay. So tier 1, it is for global backbone. It will be acting as a global backbone. Tier 2 will be regional network and tier 3 will be directly to the end user. So tier 3 is responsible for delivering the internet to the end users. Fine. Any doubts, ma'am? So network, internet, it is a network of networks, right? So how a packet is transmitted. So when a packet is nothing but a small chunk of data. Okay, so if it is transmitted over the internet, it will not travel to a single network, right? So the packet passes through many different types of networks. So all these things will be controlled by different organizations, or even to be specific, it will be controlled by different ISPs. Okay, before reaching the destination, it will be controlled by different ISPs. Okay, so the journey begins in local access network. First, it will clear with the help of local ISP, that is tier 3, okay, Wi-Fi, mobile network, which will be connected to the tier 3 ISP. So from there, it will be handed over to tier 2. Okay. So then it will be passing the tier 1 ISP and it will be reaching the destination. So depending upon the route and destination network, it will be uh, connected to different tier 1s and tier 2s. So the routers will be responsible for it will be finding the destination address in the packet, and it will be deciding where it should forward the packet so that it will reach the destination. So this decision, it depends upon how the packet is getting traveled, whether it should reach passes different cities, countries, or even continents. Okay, so here it will be done by hop forwarding. Okay, so the destination until it reaches the destination network, uh, it will be decided by the router. Okay, so longest prefix match will happen and it will be routed and it gets connected to the destination. The packet will be uh, given to the destination. What are the goals for the internet architecture? The goals of internet architecture. So the goals, uh, it should be, there will be many goals, right? Global, scalable, flexible communication system. So together with that, it should support multiple types of services. Okay, so I need to support simple file transfer, web, uh, web browsing, even video streaming, voice calls, online gaming. Everything is different types of services, right? So it should support different types of services. So these services differ in speed, latency, reliability requirements, right? So if I'm taking video conferencing, so even ours is a video conferencing like service, right? It needs a low latency. Whatever that I annotate in the slide, if it is reaching after 5 minutes, there is no use of this session, right? So a lower latency is required. So prioritized reliability is required. So file transfer, it is not required a low latency, right? So it depends the based upon the service, the speed, latency, reliability, everything differs, right? So architecture must also accommodate a wide variety of networks. Okay, so whether it is a wired network, a wireless network, a fast network, slow network, reliable network, or lossy network, it should accommodate, it should adopt to everything. Five from the wireless communication even to the fiber optic communication, right? Another goal is it should allow distributed management. There should not be single entity owns the entire network, but each network should be independently managed so that it can be cooperated for end-to-end communication. Okay, and also it must be cost. It should be cost effective. So global communication is required, but it should not require any complex or expensive infrastructure. Fine, and also it should many different networks differences between the networks will be there, right? So architecture must handle all these differences. So the different address formats, like some will be using IPv4, some will be using IPv6. The performance will also vary based upon the bandwidth, latency, the packet size vary, the loss rates vary, pattern, error handling methods. Some uses CRC, some will be using parity, event parity, or odd parity. Okay. So routing, all these things will differ. So these are the primary goals for the internet architecture, right? So what are the design goals of the internet? So the internet must be, first one, it should be resilient. Resilient in the sense the communication should continue even if some of the networks fails or some of the systems fails. It should ensure uninterrupted connectivity. Okay, even if some of the systems or some of the routers, networking devices fails. Okay, so that is the first one. The second one, it should support multiple types of communication service, like reliable service, okay, time sensitive service. We have discussed previously uh, in the previous slide itself, right? The architecture must even adopt various types of networks. It should adopt wired network, wireless network, fiber optic networks. So, irrespective of differences, bandwidth, delay, technology, it should adopt to all the architectures. And the internet must allow for distributed management. There should not be single authority, right? And also, it should be cost effective. In the previous slide, it's discussed. And the design should make it easy to attach new host. Okay, adding a device to the internet, it should require minimal configuration time and minimum effort. So if I'm having an IP address, if I'm if I'm uh, purchasing a local if I'm getting an access with the help of a local ISP, that is Type 3 ISP, immediately it should be connected without any effort. It should be connected. So the scalability, accessibility must be very high. Okay, and the resource usage must be accountable. So we should monitor, measure, and manage how the bandwidth, routing parts, and other network resources are used. Okay, in order to provide the access and also to identify the misuse. Okay, so the layered architecture. Now we'll see the layered architecture of the internet. So internet's architecture, already we have seen it is a layered architecture. The functionalities will be divided into different layers, right? And each and every layer is responsible for specific task, right? So that each layer will be implementing a set of functionalities. Functionalities like reliable data transfer, addressing security, Ethernet, collision detection, real-time guarantees. Okay, so certain layers ensures reliability with the help of sequence delivery of data. Others will help in addressing and routing. Right. So even additional functionalities to be provided. What are the additional functionalities can be provided, like security, collision detection, okay, real-time performance guarantees can be provided. Okay, so what are the advantages of having a layered approach? So each layer will have a specific task. It will be providing services. Okay, and it relies on the services provided by the layer below, and it offers the services to the layer above. Okay, so the modularity will be hidden. So how the implementation details will be hidden. That is also another advantage. Okay, so one change, whatever the change that happens within one layer, without affecting others, it gets supported. It will be easily supported, easily maintained, and easily it can be evolved. Okay, why? Because the details will be hidden. That is the advantage. So, but the layered approach, even it gives the disadvantages as well. So, layering, we have drawbacks as well. So, the duplication of the functionality. The best example is error correction, flow control. So, even the transport layer will be doing error correction, flow control, and also the data link layer will do error correction and flow control. But both the things will happen in two different things. That is process to process. In the process to process communication, the flow control error correction will be handled by the transport layer. But the data link layer, node to node error correction and flow control will be happen. Okay, so the duplication will happen, and the different layers they require access to the same information. Okay. So sometimes it can lead to inefficiency or redundant processing, right? And the third disadvantage is that uh, they have a negative impact on the performance. Okay. So in real time or high speed environments, the overhead matters, right? So it results in negative impact on the performance. So these are the advantages and disadvantages of the layered architecture. So network architecture, we have seen two types of architectures. You would have studied two architectures, OSI and TCP/IP architecture. TCP/IP is the internet architecture. Okay, TCP/IP, how many layers will be there in TCP/IP architecture? You will be having application layer, transport layer, internet layer, the network layer. Here it will be referred as internet layer, and the link layer, that is the data link layer. The last layer is the physical layer. Okay. So even sometimes the link layer will be representing the data link layer and the physical layer. Four layers will be there. Right? This is the OSI architecture. We have seen OSI architecture already, right? Just now we have seen. So what are the responsibilities that also we have seen in detail? So physical layer, actual transmission of bits. So here, physical layer, the data will be represented in terms of bits. The data link layer, the data will be represented in terms of frames, right? So network adapter will be responsible for getting the packets, and the frames will be delivered. It will be received, and it will be converting the frames into packets. So the network layer, routing and addressing will be taken care by the network layer. Here the data will be referred as packets. Okay, these are the lower three layers. So higher layers are transport layer, process to process communication. The data will be referred as segments here. Okay. So session layer will be providing sessions and dialogues will be provided. Okay. And the presentation layer, encryption, compression, everything will be taken care by the presentation layer. Application layer, actual application. So standardized common types of exchanges. So in these three layers, the data will be represented as data itself. Fine. So internet architecture, already we have seen this, right? Protocol graph. So moving on to the next topic. Any doubts? Any doubts, ma'am? So internet architecture, it will be defined by IETF, Internet Engineering Task Force, right? So it is a network of networks. We'll be having a layered architecture, end-to-end principle will be there. Okay. So there'll be a role of you have an internet architecture board. So that will be referred as IAB, Internet Architecture Board. It is a committee of Internet Engineering Task Force. Okay, they'll be providing architectural requirements for IETF activities. Okay, they'll ensure internet continuity, how the internet is being evolved. Okay, even if the architecture platform is different, how it is being evolved. Okay, and what are the three main features? So it does not simply strict layering will not be provided. So it will not imply the strict layering. Rather than the layers, the functionalities, the application will be free to bypass the defined transport layers. So it will be directly using IP or underlying networks as well. Okay. And also, an hourglass ship So it is wide at the top and it will be narrow in the middle or wide at the bottom. Okay. So IP will be serving as a focal point for the architecture, in the internet architecture. Okay. So if a new product protocol has to be included, so there is no that there should be a protocol specification, and the implementation of the specification has to be represented so that it can be newly officially it can be added into the architecture. So those constraints are given by the IETF. The specific requirements, specifications, implementations, how it is implemented. So all those things, if a new protocol has to be included inside the architecture, so a specification and also the how it is being implemented. Okay, everything has to be included and it will be it should be submitted to IETF. If it is authorized, then the new protocol can be easily added. Okay, so what is the next generation internet design? So that is what the question is, right? So this is what the last topic in our today's session. So next generation internet. What is the constraints for the next generation internet design? Fine. First one is the application. So application, uh, it should provide a flexible, secure, scalable network infrastructure. Okay, so it should shift from the traditional centralized system to the agile dynamic distributed architectures, right? And also it should support middleware systems. So middleware will be the between the applications and the users. Okay, they are called as middlewares. The internet architecture even it should support the middleware and also quality of service. The quality of service, different services they require different uh, requirements, right? Like bandwidth, priority. So if we are making a voice call, okay, so the priority should be given higher for the voice calls rather than for sending the files, okay, file transfer, okay. And also internet traffic engineering is required. So how the traffic is routed. So if I want to balance uh, the load between the routers, internet traffic engineering is required. So if one router is being loaded all the time, what will happen? Sometimes it fails, right? So it will reduce the, or it will collapse the entire network. So that should be avoided. In addition to that, we need to provide security and architecture. It should not be any architecture specific. Right? These are the specific characteristics of the next generation internet design. Right? Any doubts, ma'am? Any doubts? No. Fine. Can anyone summarize today's class? Just tell me the topics that we have discussed in the today's class. Rest of the things we'll see in the next class. What are the topics that we have seen in today's class, Kanam?
Ma'am, we discussed network architecture, OSI, and TCP/IP model.
Okay. So we've started with computer networks. What is a network? Network functionalities. What are the five components of the network? Right. What will be there in the edge of the network? What will be there in the core of the network? Okay. In order to provide the proper communication, what is a protocol? How the encapsulation will happen? A protocol graph. Then we have seen the architectures. OSI architecture, yes, and also TCP/IP architecture, a connection service, connectionless service. What is an access network? Guided medium, unguided medium, ISPs, hierarchy of the ISP, three ISPs, Tier 1, Tier 2, Tier 3, right? And the design goals of the internet and internet architecture we have seen in today's class, right? So a few more topics we need to see that we'll see in the next class. If you don't have any doubts, you can leave the meeting now. Thank you, Ma.
Thank you, ma'am.
Thank you. Thank you, Ma.